Hello. So a little bit more on the optimization we are doing in order that uh, hundreds of students can answer the quizzes online. And so what I've done, uh, we have optimized the accesses to the database, and we had problems before in the around the get quizzes. For instance, when there are a lot of quizzes, so we optimize the queries and we wrote very specific queries so that we could just get the data that we really need. The price was that we lost a little bit on reusability because now these queries contain business logic in some sense, contains rules that says what does it mean that the quiz is finished or closed, or what is an open quiz. Uh, but we achieved, so we improved the performance in the sense that this value was reduced. This is a test. These are values that are just run in my machine so that I can compare with the same data in the database. And this was a test for 100 people answering a 5 question quiz, and these 200 people answering a 5 question quiz. And we noticed that now what we have here is that so it is 5 questions because you have when you submit the answer, we have 500 answers and you have 100 threads executing these that simulate the users. And the point now is whether we can optimize it more. And actually can go a bit further in optimizing the accesses to the database. And if we go further and further, what's going to happen is we're going to just get rid of the the domain model and start having transactional scripts that transaction scripts that basic what they do is just you get the data, do all the things, set the database and change, and we can really optimize that way. But then the code will start not being that we will lose on reusability. So I'm going to propose a different thing, and this is something interesting when you do this kind of optimizations because you can sometimes decide to change a bit the functionality. And the idea is here is that we are doing a lot of requests on the database, and actually, when you have these client-side applications that use JavaScript, you can do a lot of things in the client and do and not invoke that often the database. And so my suggestion now is basically that you just focus on you get the quiz, you do everything on the client on the browser, and at the end you submit the answer. So what we intend to do in this optimization is basically you don't have the submit answer, you just have the conclude quiz, and when you conclude the quiz, you send all the answers. Okay. Of course, this may have a little bit of impact, for instance, in terms of if a failure occurs, for instance, if the browser crashes. Of course, in this case, you will lose the information. Of course, then you can program also the client in a way that you can keep these on the client side, okay? And when you relaunch the browser, basically you have the information there. We are not going to do it, but I'm going to just show you what we have done and what is the difference in terms of performance running for the same profile. Probably the best way to understand what we are doing is looking at the new JMeter script, and what we are doing basically here in this, we are running. Actually, we run for 5 questions, okay, and in the setup is similar of the previous setup. What we have done basically, you just have a loop to create 5 questions, then you just get the questions IDs here, okay? And then you use these questions IDs to create the quiz. And as you have seen, I just use this bin shell preprocessor to define this variable. And so you can have the payload dynamically generated here, okay? So you have the payload dynamic generated there. Okay, so you generate the quiz here, and then what we do on this side, you authenticate. So you have here several students, okay, 200 students answering the quiz, and you get the available quizzes just to test the load of getting the users getting the quizzes. And then we have this start quiz, okay, where we start the quiz and then the conclude the quiz. And that's the part we have to change, because when you're going to conclude the quiz, you need to send all the answers. And again, we use a bin shell processor, and basically with a cycle we just build the data object that we're going to send in the answer, and then so you create these answers object that contains the option ID, time taken, sequence, question answer ID that is necessary to send, and then basically you use it there. Okay, and that's another dynamically generated payload. And when you run these, well, we change the code, okay, nothing new. Basically, we just remove from the client side every time you just select one question. You do nothing, just store it on the client side. But when you finish the quiz, you send this, so the conclude method is going to receive it, okay? But what I'm going to show you now is what is the differences. So I run for the same, and for 200, we'll see that, so these values are pretty the same, similar, but now the difference is that instead of doing 900 invocations on the server, you just do 400 invocations. So you reduce, but you pay a price. And the price is now that the conclude quiz takes a while. Look, here the conclude is, but every time you submit, so the conclude takes a while. You may think that probably is not that bad, because although all the students start at the same time, so I'm always thinking in terms of optimizing the system according to a particular workload. And in this case, you may think that students do not finish the quiz at the same time. So this is more manageable in terms of performance, because, okay, you have 200 students that start at the same time, but they will finish along the time. And this changes a lot, performance changes a lot. I'm not going to show you, but the performance changes a lot if you have few. So this value that is quite high, if you try to conclude a quiz if with 2 or 3 users, is order of 500 milliseconds or so. Okay, maybe I can even try to show this to you. So that's one point here related with this delay now when you do this, when you just do everything, you submit everything at the end. Okay. Another thing that now we're can discuss, and this is the motivation for the next video and the next optimization, is, can I optimize this? What I'm doing here actually, well, here I'm just setting the quiz answer and setting each one of the question answers. Okay, can I optimize it? And probably there are several verifications. Okay, and I'm gonna show you that yes, we can optimize this further. And this is another technique that you can use for the implementation. So as sought for the next optimization, look at this. So with 100 users, we have around 11 seconds to latency to deliver the quiz, to conclude the quiz, okay? But if I run a single one, for instance, a single one here, if I run a single one, what I get here is much less, and is around 1 second. Okay, let's see again. 1 second. It can be even sometimes I can get around 700 milliseconds. Okay, so the point is that one way to optimize when you have a lot of load is to execute sequentially, or at least execute in parallel, corresponding to the capabilities of the server, the number of cores, your disk, and sometimes it's much more performant to basically execute at the same time the number of corresponding to more or less the number of processors, a little bit more because of the overhead of blockings and things like that. So and we are gonna what we are going to look at is an idea how can we optimize this, okay? And that's the next optimization. I hope you enjoyed this one, okay? And that's it, okay?